I'm Anthony Pulcari, and right now we're talking about volume today. Volume. Got my buddies Scott and Jay to talk about SI units and definition. Boys, take it away.
Volume is the amount of space that a substance or object occupies, or that is enclosed within a container, especially when breathed.
The base unit for volume in the SI system is the cubic meter. Other commonly used units around the world are the liter, the cubic centimeter, and the milliliter.
Well, I'm just going to need to find the volume of a solid real quick. The next match was over here. We're going to find out how.
We're about to find the volume of this base of this cube right here. I'll get the length.
I'll get the height. I'll get the width, boys. Height is 1 meter.
The width is 1 meter.
I have the length of 1 meter too. So that's... meter. Hello everyone, I'm Anthony Pulcari. Here today I'm going to show you how pipette, how it works, and how it relates to volume. Now we have water right here. I'm going to put this pipette in the water. As you see, there's a little button on top here that I'm going to pull up. And see as there's some water has accumulated in the top here. Now, I'm going to use the force of this button and push the water out. And remove the volume in the pipette. So that's how we contract and add volume to a measuring device using a pipette. You use the force of the button to shove the water out.
Hi, I'm Connor Delaney, and this is a graduated cylinder. So at first glance what you're going to notice is this yellow thing, and that's just so that it doesn't shatter if it tips over and hits the table. But also what we'll see is some of these little measurement lines here, and that's going to tell us how many milliliters of whatever you're measuring are in there. So you can use it to measure liquids, but you can also use it to measure solids using Archimedes' principle. And I'll demonstrate that. So we have this solid, the cylindrical solid here. And just by putting this in the cylinder, you'll notice that the water level went up a little bit. So the difference between the water level now and where it was is going to be the volume of this solid.
This is a eudiometer, a graduated glass tube in which mixtures of gases are made to react to an electric spark. It can also be used to measure changes in volume of gases during chemical reactions.
As you can see, it has more lines of milliliters than the other graduated cylinder that we use, allowing you to get
More precise measurements.
Yeah, more precise measurement with more decimal places.
Alright, so one of the cool things about volume is sometimes you can measure the volume of matter with nothing other than a ruler or some measuring device, a device to measure length, and some geometric formulas. So I'm going to explain some of those. For these three shapes, the formulas are essentially going to be base times height. So more specifically, you have the rectangular prism here with a formula of length times width times height. This cylinder here has a formula of radius squared pi, that's going to give you the base, times height. And this triangular prism here has a formula of 1/2 length times width, that's the base, times height. Next up, you have some more museum quality drawings, a cone and a pyramid, and the formula for these two are essentially going to be 1/3 base times height. So again, in more detail, you have the cone as radius squared pi, that's the base, times height, but also you need that 1/3 there. Then you have the pyramid here, and that's going to have a base area of 1/2 width times length, or length times width. And then to make it a formula, to complete the formula, I guess, you have to multiply it by height, and again by 1/3. A sphere is a little bit different. Since it only has one dimension, this radius here, which is the distance from a point in the very center to the outermost layer, your formula is going to be radius cubed times pi times 4/3, or 4/3 r cubed pi. And as you can see, you can get into some pretty complex shapes, and they're going to have some pretty complex formulas. So you have the icosahedron, octahedron, dodecahedron, and again, pretty complex with the formulas. Thanks for watching.
Okay, so now we're going to examine some common metric units for volume. So the nice thing about the metric system is that every metric unit is going to be the same dimension based on the prefix to what the basic unit is. So in the metric system, the basic unit of volume is going to be the liter. This is your starting point, and then from there you can work up and down depending on how much the value or size of a liter actually is. So we take a liter as a basic unit. We can go up to the decaliter, which is 10 liters, or the hectoliter, which is 100 liters. From there we can go to the kiloliter, which is 1,000 liters. So each one of these units works in increments of 10, 10x, and then that's another 10, and another 10x. So the highest amount you can get, or most commonly used, is a kiloliter, which is 1,000 liters. To work back down, you can have the deciliter, which is 1/10 of a liter. So that's 10 to the negative 1. So then from there you can see the centiliter is 1/100th of a liter, 1/1000th of a liter. So it's just the opposite of what you have up here and down there. They work equally in both ways. So there you have it. That's metric units for volume.
So you're trying to find the volume of a cube. So let's first start off and draw a cube. With our red ink. And now we know the formula for the volume of a cube is length times width times height. So now let's label this. So let's say the length was 6 inches, the width being 3 inches, and the height, let's call that 9 inches. So now we're going to multiply length times the width. So let's do 6 times 3, and then let's multiply by the height times 9. Now we have 18, 6 times 3. Now multiply that product by 9. And now let's just do the sidebar math, 18 times 9, which will give us 162. Now we know, doing volume, that the units are cubed. So we'll do inches cubed. And that is how you find the volume of a cube. So now, folks, we're going to find the volume of a cylinder. I'm going to draw my cylinder with some red ink. Let's say this cylinder is a can of famous Campbell's soup. So we have the formula, which is pi times radius squared, then times the height. And let's label some dimensions. Let's say we have the radius of the Campbell's soup is 3 inches, and the height is 9 inches. And pi equals 3.14, so you put 3.14 times radius squared, 3 to the second is 9. We multiply this out first, and we get 28.26. And now we gotta complete this problem by multiplying by the height. So we multiply the product times 9, and we will get 254.34. And of course now we have cubed with its volume, so let's do 254.34 inches cubed. And that is the volume of our wonderful Campbell's chicken noodle soup. Let's conclude with the volume of a pyramid. I'm going to take some blue ink and do a pyramid. Now the formula for the volume of a pyramid is length times width times height, all divided by 3. It's sort of like the area of a triangle when it's divided by 2, the base times the height, but instead we're dealing with a solid, so we add the cubed. So let's label the length as 3 inches, the width is 2 inches, and the height being 5 inches. So we'll do 3 times 2 times 5, and we'll divide all of this by 3. So 3 times 2 is 6, times 5 is 30, and divide that by 3, and we have the volume of the triangle equals 10 inches. Now remember, we're still in volume, so we put cubed. And here's the volume for a pyramid.
Okay, now that you know the formula for volume, it's time to take that knowledge a step further and understand how to manipulate the formula for volume. So let's imagine a scenario in which we have a volume of 22 millimeters cubed, and we have a width of 2 millimeters and a length of 5 millimeters. So now, taking this knowledge, we have to turn V equals LWH to solve for H. We want to isolate H and get H all on its own. Now, to do this isn't very difficult. This just takes some basic algebra skills, but nevertheless, we should still take a look at this. So we're going to divide length times width out of LWH, length times width and height, on both sides, so that we're left with height equals volume over length times width. So now we can plug in our values. So 22 millimeters cubed divided by 2 times 5 millimeters, and that's going to bring us 22 millimeters cubed over 10 millimeters squared. And then taking that value out of there, just some basic division, we're going to end up with 2.2 millimeters as our height. So once again, this is not terribly difficult, but it's still very important to understand this, especially as we get further with volume. An example of volume in our regular everyday life is this water bottle. It contains 500 milliliters of water, as seen right here on this measurement.
And here's a fun fact to keep us all entertained. 1 centimeter cubed equals 1 milliliter.